Hi, I'm Ms. Wong. Today we're going to do the fifth video in circular functions and we're going to look at symmetry properties. Let's look at a unit circle. It's going to be a little bit tricky, so stay with me. Let's pick a point on a unit circle, and if that's the angle, then that point is going to be the point theta, theta. Now, if I picked a point with the same angle coming from the left side, then the angle of this point will be called, what is that going to be, that angle from here all the way to here? Well, we know from here all the way to here is pi, or 180. So if I go from there and I stop there, it will be the same as doing pi and then minus theta. Or in other words, that whole thing minus that little thing. So this point here, if this is theta, then this point here with the same height would be pi minus theta. Now, why did I pick that point over there? We can see some patterns in here. So we can see that the height of these 2 points are the same, and also the distance between the center to those 2 points is also the same. How does this help us? Well, in quadrant 1, we saw that sine is equal to the y value and cos is equal to the x value, and we saw in the last video that tan is equal to y over x, or sine over cos. What about this side? We can see that the point of pi minus theta over here, that the sine is, your y value is the same, because look, the heights are the same. So in quadrant 2, sine of pi minus theta, so this point here, is the same as sine of pi. What about cos at this point? Well, the distance, the x value looks the same, except the x value on this side is negative. So cos of pi minus theta is the same as cos theta, but negative. What about tan? Well, we know in the third video where we talked about tan, that tan is positive or negative in the second quadrant. It is negative. But it also makes sense if we look at tan as being y over x, because if tan was sine over cos, so sine is positive and cos is negative, then tan has to be negative. So either way, whichever way you want to look at it, tan is negative over here, and the value would be the same. So tan of here would look like that distance there, whereas tan over here would look like that distance there. So same distance, but negative. What can we do with this information? So this is what it means by being symmetrical, as in it has some values that are the same, and we just have to check if it's positive or negative. So let's look at an example to see how this comes in as being very useful. If I have sine theta over here as being 0.4, so the y value is 0.4, what would sine theta minus theta be? Well, sine theta minus theta would be exactly the same. So therefore, if I know that sine theta is 0.4, then sine theta minus theta is also 0.4. What about if I had cos theta is 0.7 over here? What would cos theta minus pi be? Well, it will be the same distance, but we know that cos is negative over there, so it will be the negative of that, negative 0.7. So try to understand how we came about finding our value without doing any calculations by using symmetry. So if we knew what cos is, then we know what cos pi minus theta is. It's a negative of that. If we knew what sine is, then we know what sine pi minus theta is. It's the same value. What about tan? If we knew what tan is, then the tan of pi minus theta would be the negative of that. Now we've done the first and second quadrants. Let's finish off by doing the third and the fourth quadrant. Let's observe what happens to the values in those quadrants. We can see again that in the third quadrant, we can see that sine would be, so the point here would be, if the angle is the same, would be pi plus theta. See, here we have pi minus theta. Here will be pi plus theta. So at pi plus theta, it will be the same y value, but the y is negative, so sine is negative. Cos is still negative over here. And tan, well, we know that tan is positive, or negative over negative is positive. What about the fourth quadrant? So here we have, again, sine is your y value is negative, and your cos is your x value, so it's positive. And negative over positive is negative, or we saw previously that tan is negative over there. So that's a lot of information, but we can simplify this and make it really easy to remember. So the values are the same, we just have to figure out where is it positive and negative. We notice that all of them are positive here. We notice that only sine is positive here, and we notice only tan is positive here, and we notice only cos is positive there. And you'll see in a lot of textbooks that they're trying to help you remember all sine, tan, cos by just thinking about A, S, C, T, and C. So just all sine, tan, cos. So all positive, sine's only one positive, tan's only one positive, cos is the only one positive. There's heaps of sayings online, such as all sweet tasting candy. So you remember the 4 letters. You'll see all student talk calmly, and all stations to Clayton, always sing to children. Let's see if you can come up with something that starts with A, S, T, C, so that you remember their order. Maybe you can just use one of these, but see if you can come up with those and then message me or comment down below. Keep it PG. Okay, what about the questions? What do they look like? So if cos is 0.3, so cos x is 0.3, what would cos pi minus x be? So you would draw a little circle and you write ASTC, and then you would say, well, if this cos x is here, cos pi minus x will be in the second quadrant, and the second quadrant only sine, S for sine is positive, cos is negative, so it'll be the same as negative cos x. So negative cos x will be negative 0.3. What about cos pi plus x? I was going to say theta, sorry. So pi plus x will be in the third quadrant, so now we are negative again, so we are negative 0.3. What about cos 2 pi minus x? So 2 pi minus x would mean we're here, and C for cos, so it's positive over there, so it is 0.3. So you can either look at your x and y as cos and sine, or you can remember ASTC to quickly view whether you're going to be positive or negative. Again, cos negative x would mean negative x means we're here, so it's the same as cos x, but it is positive, so 0.3. One last example and then we're done for today. You can pause the video and try it yourself, or just follow along if you're not confident, and then rewind and try it yourself after. So here we have if tan x equals 2.3, and remember that cos and sine can be up to 1, but tan can be bigger than 1. If you're not sure, watch the video number 3 or 4, the video on tan. So anyway, so if tan x equals 2.3, what is tan 180 minus x? So we have to think, where is 180 minus x? It will be in the second quadrant. And in the second quadrant, only sine is positive, so tan is negative, so it will be the same as negative tan x. So negative 2.3. Tan of 180 plus x, where are we? 180 plus x is the third quadrant, and tan is positive there, so it will be the same as tan of x, which is 2.3. What about tan of 360 minus x? So 360 minus x, we're in the fourth quadrant, only cos is positive over there, so then tan is negative, which means it is negative 2.3. So remember the steps that I'm doing. So first I draw the circle ASTC, then I ask myself which quadrant am I in, and then I ask myself am I positive or negative, and then I can put the answer in. So ASTC, which quadrant am I in? Am I positive or negative? One last time. So ASTC, which quadrant am I in? Am I positive or negative? And then write the answer. So let's do that. Negative x, so which ASTC, which quadrant am I in? Negative x would mean over here, so in the fourth quadrant. Is tan positive or negative? Tan is negative because only cos is positive there. So tan is negative, then we have negative tan x, which is negative 2.3. Thank you for watching, and I'll see you next time. Bye!